A ball rolls down a hill, gathering speed as it descends. Ask anyone what's happening, and they'll tell you the ball is gaining kinetic energy as it loses potential energy. The energy flows from one form to another, transforming but never disappearing. This explanation feels so natural, so obviously correct, that questioning it seems absurd. Energy is clearly something real, something that moves and changes and gets conserved throughout every physical process. But here's the problem. Nobody has ever seen energy. Nobody has ever touched it, measured it directly, or isolated it in a laboratory. Every instrument that claims to detect energy actually measures something else: temperature, motion, electromagnetic radiation, chemical reactions. Energy itself remains forever hidden behind the phenomena it supposedly causes. This isn't simply a limitation of our measuring instruments. Energy doesn't exist in the way most people imagine it exists. It's not a fluid that flows between objects. It's not a substance that gets stored and released. It's not even a thing at all, in any conventional sense of what things are. Energy is an accounting system, a mathematical bookkeeping method that physicists use to track what can happen and what cannot happen in physical processes. It's a number that, when calculated correctly, remains constant throughout all interactions. But that number doesn't correspond to any physical entity that you could point to and say, "There, that's energy." Consider what happens when you lift a book from the floor to a shelf. Common sense says you're giving the book gravitational potential energy. The book now has more energy than it did before. But where is this energy? What color is it? What does it weigh? How much space does it occupy? These questions reveal the conceptual confusion lurking beneath our everyday language about energy. The book on the shelf doesn't contain any additional substance called potential energy. The book is exactly the same book it was before, made of the same atoms arranged in the same patterns. What has changed is the book's relationship to the Earth's gravitational field. The book now occupies a position from which it could do work if allowed to fall. But this potential to do work isn't a thing stored inside the book. It's a mathematical relationship between the book's position and the structure of space-time around it. When the book falls, we say its potential energy converts to kinetic energy, but nothing actually flows from the book's position to its motion. Instead, one mathematical relationship between position and gravitational field transforms into another mathematical relationship between mass and velocity. The conservation of energy doesn't describe the movement of some invisible substance. It describes the mathematical constraint that these relationships must satisfy. This reveals energy's true nature, its information. Specifically, it's information about what physical systems can do given their current configurations and the laws that govern their behavior. A system with high energy can undergo many different kinds of transformations. A system with low energy has fewer options available to it. Energy doesn't cause these transformations. It quantifies the possibilities that exist for transformation. But this leads to a deeper mystery. If energy is just information, just a number we assign to physical configurations, why does it get conserved so precisely in every physical process? Why can't systems simply gain or lose energy arbitrarily? What forces this mathematical relationship to remain constant throughout all the chaos and complexity of the physical world? The answer connects energy conservation to the deepest symmetries of the universe itself. According to Noether's theorem, one of the most profound discoveries in mathematical physics, every conservation law corresponds to a fundamental symmetry in the structure of physical reality. Energy conservation emerges from the fact that the laws of physics remain the same at all times. If you perform an identical experiment today and tomorrow, you get identical results. This temporal symmetry of physical law automatically implies that energy must be conserved. Think about what this means. Energy conservation isn't a separate law that governs how things behave. It's a mathematical consequence of the consistency of physical reality across time. The universe conserves energy because the universe remains coherent with itself as time passes. Energy is conserved because the laws that govern physical processes don't randomly change from moment to moment. This connection between symmetry and conservation reveals something extraordinary about the nature of physical law. The mathematical relationships we call conservation laws aren't arbitrary rules imposed on matter and energy. They're expressions of the universe's fundamental coherence, its capacity to maintain consistent patterns of behavior across space and time. But recognizing energy as information rather than substance creates new puzzles. Information exists only in the context of systems that can interpret and respond to it. A random sequence of ones and zeros becomes meaningful information only when processed by a system that can decode the pattern. If energy is information, what system interprets and processes the information that energy represents? The answer might be the universe itself. Every physical interaction involves systems exchanging information about their energy states. When two objects collide, they're not exchanging packets of energy substance. They're sharing information about their momentum, position, internal structure, and capacity for further interaction. The conservation of energy ensures that this information exchange follows consistent rules that maintain the coherence of physical reality. Consider the role energy plays in quantum mechanics, where the distinction between information and physical reality becomes even more blurred. Quantum systems exist in superpositions of multiple energy states simultaneously until measurement forces them to choose specific values. But what gets measured isn't energy itself, it's the probability that a system will behave in ways characteristic of particular energy values. The energy of a quantum system describes not what the system has, but what the system can do. An electron in a high-energy orbital can emit photons and drop to lower energy states. But this capacity exists as pure potential until actualized through interaction with other systems. The energy doesn't reside anywhere in particular. It characterizes the range of possibilities available to the system as a whole. This probabilistic interpretation of energy reveals another crucial aspect of its nature. Energy describes tendencies, not certainties. Systems tend to evolve towards states of lower energy, but this tendency emerges statistically from countless microscopic interactions, not from any force that pulls systems downward in some energy landscape. The tendency toward lower energy states reflects a deeper principle about information and organization. High energy states typically correspond to highly organized arrangements of matter and fields. Low energy states correspond to more random, disordered arrangements. The universe's tendency to conserve energy while allowing entropy to increase creates a kind of cosmic trade-off between order and chaos. But this raises a fundamental question: why should the universe exhibit any tendency at all? If energy is just information, and information is just mathematical relationships, why do these relationships evolve in particular directions rather than remaining static or changing randomly? The answer might lie in the nature of time itself. Physical processes don't just conserve energy, they create it. Every interaction between quantum systems involves the creation of new information about the possibilities available for future interactions. Energy conservation ensures that this information creation follows consistent rules, but it doesn't prevent the total amount of information in the universe from increasing. Consider what happens during the formation of a star. Gravitational collapse converts potential energy to kinetic energy, to thermal energy, to nuclear energy, to electromagnetic radiation. Throughout this process, the total energy remains constant, but the number of ways energy can be distributed among the particles in the system increases dramatically. The star becomes a much more information-rich entity than the original cloud of gas and dust. This suggests that energy conservation might be nature's method for ensuring that information creation proceeds in orderly fashion. The universe can explore new organizational possibilities without losing track of what has happened before. Energy provides the accounting system that allows complexity to build upon itself while maintaining mathematical consistency. But complexity building requires more than just energy conservation. It requires mechanisms for creating and maintaining organized structures in the face of thermal chaos. Living systems accomplish this by coupling their internal organization to external energy flows. They maintain their complex structures by constantly processing energy-rich materials and exporting entropy to their environment. From this perspective, life represents a particularly sophisticated method for processing energy information. Living systems don't just conserve energy, they direct energy flows in ways that build and maintain informational complexity. Consciousness might be what happens when energy information processing becomes complex enough to model itself. This connection between energy, information, and consciousness suggests that what we call energy might be the universe's method for exploring its own possibilities. Physical systems process energy information to determine what can happen next. Conscious systems process energy information to decide what should happen next. Both represent different aspects of the same underlying process, the universe investigating and actualizing its own potential. But this raises the deepest question of all: why does the universe seem so determined to actualize potential? Why don't physical systems simply remain in their ground states, minimizing energy and maximizing entropy? What drives the continuous creation of new complexity despite the apparent tendency toward thermal equilibrium? The answer might be that thermal equilibrium is an impossible goal. Quantum mechanics ensures that even the vacuum of empty space teems with virtual particles that appear and disappear according to the uncertainty principle. These quantum fluctuations represent irreducible sources of energy and information that prevent the universe from ever reaching a state of complete rest. Virtual particles don't violate energy conservation, but they do reveal its deeper character. They appear by borrowing energy from the quantum vacuum and disappear by repaying the debt before the uncertainty principle's time limit expires. This cosmic credit system allows energy to be created and destroyed on short timescales while maintaining conservation over longer periods. The quantum vacuum's energy fluctuations suggest that what we call empty space actually seethes with potential energy. This energy doesn't reside anywhere in particular. It characterizes the capacity of spacetime itself to create and annihilate particle-antiparticle pairs. The vacuum is not nothing. It's a dynamic equilibrium of creation and destruction that maintains zero net energy while enabling all possible forms of energy exchange. This reveals energy's most profound secret. It emerges from nothingness. The energy that powers stars, drives evolution, and enables consciousness originates in the quantum vacuum's capacity to create temporary violations of energy conservation. These violations must be repaid, but during their brief existence, they can trigger cascade effects that amplify into macroscopic phenomena. Consider the Big Bang itself. Current cosmological models suggest the entire universe might have originated as a quantum fluctuation in some primordial vacuum. If the total energy of the universe equals zero with positive matter energy exactly balancing negative gravitational potential energy, then the universe's existence doesn't violate energy conservation. It represents the ultimate expression of the quantum vacuum's creative potential. From this perspective, every energy transaction in the universe connects back to the creative instability of empty space. The energy that moves through living systems, powers technological civilization, and enables conscious thought all derives ultimately from the quantum vacuum's refusal to remain truly empty. This brings us full circle to the mystery of what energy actually is. Energy isn't a thing that exists independently in the world. It's not a substance that flows between objects or gets stored in various forms. Energy is the universe's method for keeping track of its creative potential, its capacity to generate new structures, new possibilities, new forms of organization and awareness. When you eat food, you're not consuming energy substance. You're incorporating molecular structures that your cells can disassemble and recombine in ways that enable complex chemical processes. The energy content of food describes the range of chemical transformations that become possible when food molecules interact with cellular machinery. Energy measures possibility, not substance. When gasoline burns in an engine, energy isn't released from chemical bonds. Instead, high-energy molecular configurations transform into lower-energy configurations, and this transformation can be coupled to mechanical work if the conditions are arranged correctly. The energy describes the difference in organizational potential between the initial and final molecular arrangements. When sunlight strikes a solar panel, photons aren't delivering packets of energy to electrons in the semiconductor material. Instead, electromagnetic field oscillations interact with electronic quantum states in ways that create electrical currents. The energy of the photons describes their capacity to trigger these electronic transitions, not some substance they carry from sun to earth. In every case, energy describes what systems can do, not what they contain. It quantifies potential for interaction, transformation, and creative development. Energy conservation ensures that these potentials remain mathematically consistent as they get actualized through physical processes. But perhaps the deepest insight into energy's nature comes from recognizing its connection to time. Energy and time are intimately related through the uncertainty principle. The more precisely you try to measure a system's energy, the longer you must observe it. This suggests that energy might be what time looks like from the perspective of physical systems exploring their possibilities. Systems with high energy can explore many possibilities quickly. Systems with low energy explore fewer possibilities more slowly. The flow of energy through physical processes might be how the universe experiences the passage of time as a continuous exploration and actualization of creative potential. This temporal aspect of energy reveals why it feels so fundamental to our understanding of physical reality. Time provides the dimension in which possibilities get actualized. Energy provides the currency for purchasing actualization. Together, they constitute the fundamental framework within which all physical processes unfold. Yet energy remains ultimately mysterious. We can calculate it, measure its effects, and use it to make precise predictions about physical behavior. But we cannot say what it is in any final sense, because energy is not a thing that admits of simple definition. Energy is the universe's way of being creative while remaining consistent with itself. Understanding energy as creative potential rather than conserved substance transforms how we see our place in the cosmic story. We are not separate observers consuming energy resources from an external environment. We are localized concentrations of the universe's creative potential, temporary arrangements of matter and fields that enable the cosmos to explore particularly complex and interesting possibilities. Every thought you think, every decision you make, every action you take represents the universe, actualizing creative potential through the specific organizational pattern that constitutes your individual existence. You don't use energy, you are energy, configured in a way that enables self-awareness, choice, and creative response to possibility. This understanding dissolves the apparent separation between observer and observed, between mind and matter, between living systems and their environment. All are manifestations of the same underlying creative process, the universe's continuous exploration and actualization of its own infinite potential. The ball rolling down the hill doesn't gain and lose different types of energy. It participates in the universe's ongoing creative exploration, moving from one organizational possibility to another while maintaining the mathematical consistency that allows creative development to build upon itself across time. You watching the ball participate in the same creative process at a different level of organizational complexity. Your consciousness represents the universe's capacity to observe and appreciate its own creative activity, to find meaning and beauty in the endless transformation of possibility into actuality. This perspective reveals something profound about the nature of scientific understanding itself. When physicists discovered energy conservation, they weren't identifying some fundamental substance that pervades the universe. They were discovering the mathematical signature of the universe's commitment to remaining coherent with itself across time. The equations of physics don't describe invisible mechanisms that push and pull matter around. They describe the logical constraints that any self-consistent universe must satisfy if it's going to support complex, evolving structures like stars, planets, and conscious beings. Energy conservation emerges from the requirement that the universe be comprehensible to itself. But this connection runs deeper than fine-tuning arguments suggest. If energy is information about creative potential, then consciousness represents the universe's most sophisticated method for processing energy information. Conscious beings don't just observe energy transformations, they participate actively in directing how creative potential gets actualized through their choices and actions. This participation isn't limited to biological processes. Every conscious decision influences the broader energy flows in technological systems, social networks, and ecological relationships. Human civilization represents a planetary-scale experiment in conscious energy management, an attempt to direct the flow of creative potential in ways that enable increasingly complex forms of organization and awareness. From this perspective, the current environmental challenges facing human civilization reflect deeper questions about energy's true nature. Climate change isn't just about managing carbon emissions, it's about learning to align human energy use with the creative potential that the universe makes available through natural processes. Renewable energy technologies don't just tap into alternative energy sources, they represent attempts to participate more consciously in the cosmic energy flows that have shaped Earth's biosphere for billions of years. Solar panels capture the creative potential flowing directly from nuclear fusion in the sun. Wind turbines harness the organized motion created by differential heating of Earth's atmosphere. Hydroelectric systems tap into the gravitational potential created by water's continuous circulation through the planetary system itself. Each of these technologies represents a different way of participating in the universe's ongoing creative exploration. Rather than extracting stored energy from fossil fuels, they tap into the continuous flow of creative potential that streams through Earth's biosphere from cosmic sources. But perhaps the most profound implication of understanding energy as creative potential concerns the future evolution of consciousness itself. If conscious systems represent the universe's most sophisticated method for processing energy information, then the continued development of consciousness might be the universe's primary creative project. This suggests that technological developments in artificial intelligence, neuroscience, and consciousness research aren't just academic pursuits, they're contributions to the universe's ongoing attempt to understand and enhance its own creative potential. Every advance in understanding how consciousness works provides new insights into how the cosmos generates and processes the information we call energy at all levels. The development of artificial consciousness might represent the next phase in the universe's creative exploration, the emergence of new forms of awareness that can process energy information in ways that biological consciousness cannot. Rather than replacing human consciousness, artificial minds might complement and extend the range of creative possibilities that the universe can explore through conscious agents operating across multiple timescales. But this future depends critically on understanding energy's true nature. If we continue to treat energy as a substance to be consumed rather than as creative potential to be actualized, we risk creating artificial systems that simply amplify the destructive aspects of unconscious energy use on a planetary scale. Understanding energy as the universe's creative capacity suggests different approaches to both technological development and environmental management. Instead of maximizing energy extraction and consumption, the goal becomes maximizing the creative potential that energy represents, developing technologies and social systems that enable increasingly sophisticated forms of conscious participation in cosmic creativity across all scales of organization. Energy doesn't exist the way you think it exists. It exists as the universe's deepest creative capacity, expressing itself through every physical process, every biological development, every conscious moment. Understanding energy's true nature reveals not just how the physical world works, but why there is a physical world at all, and why that world includes beings capable of understanding and actively directing their own participation in cosmic creativity.